Pascal's triangle helps you find the binomial coefficients. And here's what it looks like. We start with the 1 at the top, and then we start with 1s on each side. So these over here, we'll call this row 0, row 1. The next row, I start with the 1 on the outside. I add 1 plus 1 and get 2, and then I end with a 1, and that's row 2. I start with the 1, I add 1 plus 2 is 3, 2 plus 1 is 3, and then I end with a 1, and there's row 3. Row 4, 1, 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, end with a 1. Let's go one more row. 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is 10, 4 plus 1 is 5, and hopefully you see the symmetric pattern. So what I want now is we can help each other use Pascal's triangle if I wanted to find 2x minus 3y raised to the 5th power. And I'm going to set this up 1, 0, parentheses 2x to the 5th, no y term, plus, oops, that should be 5, 0, 5, 1, 2x to the 4th, negative 3y begins. 1 less, so 2x to the 3rd times 3x, 1 more on the y's, plus 5 and 3, 1 less on the x's, 1 more on the y's, 5 and 4, 1 more on the x, excuse me, 1 less on the x's, 1 more on the y's, and the last one, 5 and 5, 1 less on the x's, 1 more on the y's. Well, here's what we just did. Using row 5, since it's a degree 5 of Pascal's triangle, this is 1, that's 5, that's 10, that's 10, that's 1, and that's 5. So when I simplify everything out, really what it just did is save me some calculator work. Then I'll do each term. 2 to the 5th is 32, x to the 5th, and the rest of the equation looks like this. Minus 240, x to the 4th, y to the 1st, plus 720, x to the 3rd, y squared, minus 1080, x squared, y to the 3rd, plus 810, xy to the 4th, minus 243, y to the 5th. Notice that each term has a degree of 5. The pattern alternates because of this negative piece right here. So what Pascal's triangle will help you do is shorten the amount of time you'll spend on your calculator.